Hello students, let us learn today basic proportionality theorem and the converse of basic proportionality theorem. In this video, we are not going to learn the proof of the basic proportionality theorem, but we are going to learn what does theorem states, and we are going to understand the meaning of the theorem so that we can use that theorem to solve some examples. So let us start with the statement of the theorem. The statement is, if a line parallel to a side of a triangle intersects the remaining sides in two distinct points, then the line divides the sides in the same proportion. So this is the statement of the basic proportionality theorem. Now we will illustrate this by using the diagram. So for this one, let us have a triangle over here. Let us name that triangle as triangle ABC. There is one line PQ which intersects two sides of a triangle, that is side AB and side AC. So line PQ intersects side AB at point P and side AC at point Q, as you can see in the diagram. And it is given that the line PQ is parallel to side BC of triangle ABC. According to our theorem, as line PQ intersects two sides of a triangle and it is parallel to the third side, this line must intersect the two sides of a triangle in the same proportion. That means, if we take a ratio of AP and PB, it must be equal to AQ and QC. This means that AP divided by PB is equal to AQ divided by QC. That means that line PQ divides side AB and side AC in the same proportion. It does not mean that AP is congruent with PB or AQ is congruent with QC. But if we take a ratio of AP and PB, it must be equal to AQ divided by QC. Let us have one example. In the same example, if the length of AP is given to be 6, length of PB is given to be 4, length of AQ is given to be 12, and length of QC is 8. As you can see here, AP is not congruent to PB or AQ is not congruent to QC. But if we take the ratio of AP and PB is equal to 6 divided by 4, and if we simplify this, we'll get 3 divided by 2. Because if we divide by 2 both the terms, we get 3 by 2. So we get AP divided by PB is equal to 3 divided by 2. The same way, if we take the ratio of two sides which are made on side AC by line PQ, that is AQ divided by QC, we have the lengths of AQ and QC as 12 and 8. So if we replace here, we get 12 divided by 8. Again, if we simplify or if we divide these two terms by 4, we get again 3 by 2. So as you can see, AP divided by PB is equal to 3 by 2 and AQ divided by QC is also 3 by 2. So from this we can conclude that AP divided by PB is equal to AQ divided by QC. So when line PQ is parallel to side BC, from this example we can conclude that AP divided by PB is equal to AQ divided by QC. That means line PQ divides side AB and side AC in the same proportion. So this is the basic proportionality theorem. Now we have its converse. So let us have the statement of converse of basic proportionality theorem. The statement is, if a line divides any two sides of a triangle in the same ratio, then the line is parallel to the third side. For this, let us consider again one triangle ABC, where line PQ divides side AB and side AC at points P and Q, and in this case here it is given that AP divided by PB is equal to AQ divided by QC. That means line PQ divides side AB and side AC in the same proportion. If it is so, then line PQ must be parallel to the third side, and the third side is BC. That's why line PQ is parallel to segment BC. So this is the converse of the basic proportionality theorem. In the basic proportionality theorem, it is given that line PQ is parallel to segment BC, and if it is so, then AP by PB is equal to AQ by QC. This time, this is a converse of basic proportionality theorem. That's why it is given that line PQ divides two sides of a triangle in the same proportion. Then from that, we have the same line is parallel to the third side, that is PQ is parallel to BC. So this is the converse of basic proportionality theorem. By using these two theorems, we can solve some examples.